Let's go over section R.3, Polynomials. There's a couple rules we should remember. For all positive integers m and n and all real numbers a and b, the following rules hold. The first rule is called the product rule. We're saying a to the m times a to the n, we're going to have to add the exponents together. For example, if I have x squared times x cubed, we're going to have to add the 2 and the 3 together, and that's going to give us x to the 5th power. For the power rule, we have a raised to the m, and then again we're going to raise that to the n. We're going to have to multiply the powers together. X raised to the 2nd, then we'll raise it to the 3rd again, is equivalent to x raised to the 2 times 3, which is just x to the 6th. So if we're going to raise an exponent to a power, we're going to multiply the exponents together. If we're going to multiply two exponents, we add them together. Power rule 2. If we have a, b raised to the m, that's equivalent to a to the m times b to the m. Essentially, we're distributing that m to each of the exponents of a and b. For example, if we have x, y cubed, this can be written as x cubed, y cubed. Similar to distribution, but we're working with the exponents. For the next rule, we have a over b raised to the m. A similar technique, we're distributing that m to each of the exponents. So we have x over y raised to the 3rd. This is equivalent to x cubed divided by y cubed. And of course we have a condition that the denominator cannot be equal to 0. Example 1, let's simplify each expression. Part A, y to the 4th times y to the 7th. If we look at our previous formula, we're going to add these exponents together. Y to the 4th times y to the 7th is the same as y to the 4 plus 7, or y to the 11th. For part B, we're going to have to multiply the numbers in the front first to each other, and that gives me 108 z to the 5th times z cubed times z squared. Now we're going to use our product rule. There are multiple z's that we need to multiply together, so that's z to the 5th plus 3rd plus 2nd. So we're going to have to add this to get our new exponent. This is equivalent to 108z to the 10th power. Example 2, we're again going to simplify these exponents. For part A, we're going to multiply the 3 times the 2. 5 to the 3 times 2 is equivalent to 5 to the 6th power. And of course I could type this in my calculator. This gives us 15,625. For part B, we're going to distribute this 3 to each of the exponents. We're going to multiply. Going to multiply this to each of the exponents. So we have 3 raised to the 4 times 3, and x raised to the 2 times 3. This is equivalent to 3 to the 12th, x to the 6th. Now we could use 3 to the 12th on our calculators. This is equal to 531,441. Part C. Again, we're going to distribute that 3 to each of the exponents. This is 2 to the 5 times 3, divided by b to the 4 times 3. I can simplify the top as 2 to the 15th power, divided by b to the 12th power. And we can simplify the numerator as 32,768 divided by b to the 12. Part D, again I'm going to distribute that 5 to each of the exponents. Now you want to be careful with that negative 2. Make sure you put parentheses around it, then raise it to the 5th power. M raised to the 6 times 5. T raised to the 2 times 5. And then Z to the 5. Now I want to be careful with that parentheses because this 5 affects both the negative and the 2. And that really matters if this is an even number. So we'll plug this in our calculators, negative 2 to the 5th. That gives me negative 32. M to the 6 times 5 is 30. And 2 times 5 is 10. And this is the simplest we can make it. This is our solution. The zero exponent rule. It states that a raised to the 0 is equal to 1 for any number except 0. What this is saying is if we have 7 to the 0, this is equal to 1. If we have 5 to the 0, this is equal to 1. If we have 1 million to the 0, this is equal to 1 also. But 0 to the 0, that's undefined. This doesn't work for 0. But any other base besides 0, it works. This is a formula you should remember. So let's try some of these definitions. Part A, 4 to the 0. Well, according to our definition, that's just 1. Part B, negative 4 to the 0. Well, according to our definition, that's just 1. Part C, negative 4 to the 0. A lot of people make the mistake of thinking this one's 1. But look at it carefully. This 4 to the 0 has a negative in the front. This negative is not affected by that 0. This is negative 1. This 0 only influences the 4. So be careful. Part D, we have negative 4 to the 0. Well, this 0 only influences this part of it, so we again have negative 1. Part E, 7r raised to the 0. This 0 affects both the 7 and the r, so this is equivalent to 1. So be careful. If there are parentheses, it affects the entire expression. If there's not, assume that the parentheses just is around the number and not the negative in the front. Example 5, we're going to add or subtract these polynomials. So the thing to remember is you can only add or subtract terms that have the same variable and the same exponent. So let's try part A. We have 2y to the 4th minus 3y squared plus y plus 4y to the 4th plus 7y squared plus 6y. Now I'm looking for like terms. I have a power of 4 and a power of 4 here. So this gives us 2 plus 4, which is 6y to the 4th. We do not change the exponent because we're adding. We only change it if we're multiplying or dividing. This is the power of 2. Let's add these together. Negative 3 plus 7 is 4. And then we'll keep the y squared. Y plus 6y is just 7y. And that's our solution for part A. Part B, we have negative 3m cubed minus 8m squared plus 4. And I want you to be extra careful. There's a negative here. You have to make sure to distribute the negative to the right side before we add
these polynomials together. This gives me negative m cubed, negative 7m squared, and a positive 3. That's from distribution right here. Now I can try to collect like terms. Negative 3m cubed and negative m cubed. That's negative 4m cubed. Negative 8m squared and negative 8m squared. That's negative 15m squared. 4 plus 3, that's just 7. So for part B, just be extra careful if there's a negative. Don't forget to distribute that first. Part C. There's no negative, so that's nice. We could just remove the parentheses. 8m to the 4th, p to the 5th, minus 9m cubed, p to the 5th, plus 11m to the 4th, p to the 5th, plus 15m cubed, p to the 5th. Now I'll have to look at it carefully to make sure they have the same variable and the same exponent. Then I can add them. This is m to the 4th, m to the 4th, and they both have a p to the 5. So these two can be added. 8 plus 11 is 19 m to the 4th, p to the 5th. M cubed p to the 5th, m cubed p to the 5th. These two have the same variables and exponent, so it's okay to add these two. So we're going to get 6 m cubed p to the 5th. In part D, we have a 4 in the front and a negative 5 in the front. So I would recommend that you distribute first. And here I'm going to distribute a negative 5. This gives me 4x squared minus 12x plus 28. We'll distribute a negative 5. That's negative 10x squared plus 40x plus 20. Again, we'll collect like terms. 4x squared and negative x squared is negative 6x squared. Negative 12x and 40x, that's going to give us, that gives me 28x, and 28 plus 20, that's just 48. So again, be careful. I would recommend distributing the number in the front first and then collecting like terms. Example 6. Let's multiply these two polynomials together. I always like to start with the first term and then distribute that to the other terms. So let's try to multiply this out. We have 3p squared times p cubed, which gives me 3p squared times p cubed. I'm going to multiply 3p squared again times 2p, 3p squared again times negative 8. So that's the first distribution. And then we're going to use negative 4p now to multiply the terms on the right. So this gives me negative 4p times p cubed, negative 4p times 2p, negative 4p times negative 8. Alright, so the second term is now multiplied to the entire right side. And we have one more. This is a 1. We're going to multiply this 1 times all of these. So we'll take our time with that. That's pretty easy to do. So we're going to add 1 times p cubed, 1 times 2p, and 1 times negative 8. So let's simplify this. We have 3p to the 5th plus 3 times 2 gives me 6. P cubed, because there's an invisible 1 here for the exponent. There's an invisible 1 here for the exponent. 3 times negative 8 is negative 24p squared. Negative 4p times p cubed. Again, there's an invisible 1. That's negative 4p to the fourth. This gives us negative 8p squared. This gives us positive 32p. And this is p cubed. This is 2p. This is negative 8. So let's collect like terms. I don't have any other p to the fifth, so we're going to copy that down. 3p to the fifth. I have this as 4p to the fourth. There's no other one, so we'll copy that down. So we have these two written. Now we'll look at the cubes. There is 2 cubes, this one and this one, which I can add to get 7p cubed. These are the squareds. We have negative 24p squared minus 8p squared. That's negative 32p squared. 32p plus 2p is 34p. And finally we have negative 8. So this isn't a difficult process, it just takes some time, and you should be careful with your addition and subtraction. Let's use the FOIL method for this problem. The F stands for the first terms, the O stands for the outer terms, the I stands for the inner terms, and the L stands for the last terms. So we'll multiply the first terms together. 6m times 4m is 24m squared. First with the first. We'll multiply the outsides together now. 6m times negative 3 is negative 18m. And now the insides, the inner terms. We have 1 times 4m is just 4m. And then 1 times negative 3 is just negative 3. This simplifies to 24m squared. I could collect like terms in the middle. Negative 14m minus 3. Let's try part B. We have 2x times 2x is 4x squared. We have 2x times negative 7 is negative 14x. 7 times 2x is 14x. 7 times negative 7 is negative 49. We could collect like terms. The 2 in the middle actually cancels out. So we have 4x squared minus 49. For part C, we have a term that's multiplied to the left side. And then we have another binomial here. I would like to multiply these two on the right side first. So this is equivalent to r squared. And then we're going to multiply these out. 3r times 3r is 9r squared. 3r times negative 2 is negative 6r. 2 times 3r is 6r again. And 2 times negative 2 is negative 4. Let's simplify. The two terms in the middle cancel out again. We get r squared times 9r squared minus 4. And we can distribute that r squared now. We'll distribute that r squared. This gives me 9r to the fourth minus 4r squared. There are some special products that we should be aware of. The first one is if we multiply two binomials together and the only difference between them is a plus or a minus sign in between, we actually cancel out the two middle terms and we get x squared minus y squared. So this is a good formula to remember. So please write that down somewhere. Remember this formula. Now, if we square x plus y, that simplifies to x squared plus 2x plus y squared. And if we square the same thing but a negative on the inside, that's going to give us x squared minus 2xy plus y squared. So these are also good formulas to remember. An easy way to remember this is to look in the middle. This one's a plus because this is a plus. This one's a negative because this one is a negative. So remember this formula. We're going to use this a lot in this semester. Part A. We want to multiply 3p plus 11 times 3p minus 11. I'm going to use our formula for part A. This is equivalent to 3p squared minus 11 squared. So we can simplify this as 9p squared minus 121. I'm using the formula, and it makes this problem pretty easy. You can also try to FOIL, but you'll get the same thing. Part B, we have 5m cubed minus 3 times 5m cubed plus 3. Again, we're going to use the formula 5m cubed squared minus 3 squared. This simplifies to 5 squared m to the 6th minus 9. And of course we could simplify that further as 25m to the 6th minus 9. For part C, we're going to use the same formula again. This is 9k squared minus 11r cubed squared. This simplifies to 81k squared minus 121 r to the 6th. For part D, we have 2m raised to the 2nd plus 2 times 2m times 5 plus 5 squared. This is a different formula because we have an addition between. So you have to be careful to pay attention to the addition between. We're using the other formula now. And of course this simplifies to 4m squared plus, we have 2 times 2 times 5, that's going to give us 20m, and finally 5 squared is 25. Part E, we're going to multiply 3x minus 7y to the 4th quantity squared. So I'm going to use our very last formula. We're going to put 3x squared minus 2 times 3x times 7y to the 4th minus plus 7y to the 4th squared. So just plug in the values into the formula. We have the first term squared, the last term squared, and then in the middle we have negative 2 times those two terms. This gives me 9x squared. 2 times 3 times 7 gives me negative 42y to the 4th. And there's also an x here, so let's squeeze that in there. And then we have 7y to the 4th is going to be squared. That gives me 49y to the 8th. So these questions aren't too hard, but you do need to remember the formula. Example 9, find each product, and of course these are going to be more complicated, but we're still going to use the same formulas. This is one term that's the same as this term. This term is the same as this term. The only difference is the plus and the minus. So I'm going to use the formula x plus y times x minus y equals x squared minus y squared.
This simplifies to 3p minus 2 squared plus 5q squared. And now I'm going to use another formula for this. Remember, x minus y squared is the same as x squared minus 2xy plus y squared. So this is equivalent to 3p squared minus 2 times 3p times 2 plus 2 squared plus 5q squared. So let's simplify this expression out. We have 3p squared, which is just 9p squared. We have this expression, which is negative 2 times 3 times 2. That's negative 12p. 2 squared, that's just 4. And 5q squared is 25q squared. Let's see if we can collect like terms. There's nothing that we can add together, so this is a good solution. Let's try part B now. I'm going to break up part B as x plus y times x plus y squared. We don't have a formula for a cubic, so we're going to just break it up as x plus y to the 1 times x plus y squared. Now I know the formula for x plus y squared. That's just x squared plus 2xy plus y squared. And now we can FOIL. We have x times x squared, that's x cubed. X times 2xy, that's 2x squared y. X times y squared, that's xy squared. Y times x squared, that's x squared y. Y times 2xy is 2xy squared. Y times y squared is y cubed. Let's collect like terms if possible. We have x cubed. 2x squared y squared can be added to this term. So that's 3x squared y. Xy squared can be added to this one. That's 3x y squared. And we'll bring down the y cubed. This is our solution for part B. Part C, we have 2ab quantity raised to the 4th power. So I'm going to break it up into two smaller products. Let's break it up into 2ab quantity squared times another 2ab quantity squared, because we know if we multiply these, we get the exact same thing back, the 4th power. So we have, according to our formula, this is equivalent to 2a squared plus 2 times 2a times b plus b squared. That's from our formula for the sum of squares. And the other side is going to be exactly the same. We're going to square 2a. We're going to add 2 times 2a times b plus b squared. So let's simplify this a bit. This becomes 4a squared plus this becomes 4ab plus b squared. And the right side is exactly the same, so we'll just copy it as it is. And now we have to FOIL. I'm going to multiply 4a squared times 4a squared. Then we'll do 4a squared times 4ab. And then we'll do 4a squared times b squared. So let's figure out what that is.
This simplifies to 16a to the 4th plus 16a cubed b plus 4a squared b squared. So take your time with this. This is a good opportunity to make a mistake. Now we're going to do the second term times the entire right side. So these are the multiplications that we're going to perform. This gives me 16a squared b squared. That's from 4ab times 4ab plus 4ab times 4a squared is 4a cubed b plus we have 4ab times 4ab, that's 16a squared b squared. 4ab times b squared is going to be 4ab cubed. And for the last set of multiplications, we're going to use the b cubed to the rest of the terms. This gives me plus 4a squared b squared plus 4ab cubed plus b to the 4th. A difficult problem, but we can do it. We just gotta take our time. Let's collect like terms. Let's collect like terms now. I'm gonna start underlining so I don't forget anything. We have 16a to the 4th. There's no other a to the 4th, so we'll copy that down. 16a cubed b can be added with 4a cubed b. That gives me 20a cubed b. 4a squared b squared can be added with 4a squared b squared and 16a squared b squared. That gives me 24a squared b squared. 4ab cubed can be added with 4ab cubed. That gives us 8ab cubed. And finally we have a b to the 4th, so we'll have b to the 4th here. Example 10, we're going to divide these polynomials. We're going to use long division. For long division, it's just the same as regular division. Suppose you're dividing 3 into 7. You ask, what do I need to multiply by 3 to get close to 7? And the answer is 2. Then you multiply 2 times 3, you get 6. You start subtracting, and then you continue the process. So we're going to do the same thing here. I'm going to ask, what do I need to multiply by 2m to get me close to 4m cubed? And that's going to be 2m squared. Now we're going to multiply this 2m squared to the terms in the front, and that gives me 2m times 2m squared is 4m cubed. 2m times negative 1 is negative 2m. Then we're going to subtract. I always put a parenthesis when I do the subtraction so that I know to distribute the negative. This negative is distributed here, so this becomes a negative, and this is actually a plus. So now this cancels out. The 4m cubed and the negative 4m cubed cancels out. Negative 8m squared. This was supposed to be a squared, my mistake, so make sure you put that there. Plus 2m squared can be added together to get negative 6m squared. And what do we do next? We bring down the 5m. And then we'll continue the process. 2m times what gives me close to negative 6m squared? Well, that's negative 3m. So we have negative 3m. And now we're going to multiply that negative 3m times the two terms in the front. This gives me negative 6m squared. Negative 3m times negative 1 is plus 3m. And again, I'm going to put a parentheses and a negative in the front. Remember, we're trying to distribute this negative. So this doesn't become a negative, it actually changes to a plus. And this net plus here becomes a negative. Now we can add this together. This cancels out. I get 2m. And then we're going to bring down that 6. So we'll put plus 6 here. Let's continue the process again. I'm going to ask 2m times what gives you 2m? Well, that's going to be a 1. And now we're going to multiply this 1 back to the front. And we get 2m minus 1. Again, I'm going to have to distribute a negative. And this means that this is a negative. And this becomes a plus. So we'll add that up and we get a 5. Now this is our remainder. To add our remainder, you're going to put plus 5 and then we'll divide it by our divisor. This gives me 2m minus 1. So this is our solution, 2m squared minus 3m plus 1 plus 5 over 2m minus 1. For example 11, you have to be very, very careful. You have to write it in descending orders of power. And notice that both of these have a term missing. They're both missing the x term. So we're going to have to add it. So we're going to write x squared plus 0x, that's my missing term, minus 4. So for any missing terms, put a 0 in front of that, so it doesn't really add it, but it gives us a placeholder. We have 3x cubed minus 2x squared plus, again I'm missing a 0x, so I'll have to add that, minus 150. For any missing terms, make sure you put a 0 for the placeholder. Now let's try the question out. X squared times what gives me 3x cubed? Well, that's going to be 3x, and then we'll distribute the 3x to the left side. 3x times x squared is 3x cubed. 3x times 0x is just 0x squared. 3x times negative 4 is negative 12x. Notice how these allow us to line up the squareds with the squareds and the cubes with the cubes. I'm going to have to distribute the negative now to the right side. This is a negative 3x cubed. This is a negative 0x. And this is actually a plus 12x. This gives us that the 3x cubed cancels out, negative 2x squared, and plus 12x. And of course, now we can bring down our next term, negative 150. Let's continue the process now. Now we're going to make a guess. X squared times what gives us close to negative 2x squared? That's going to be negative 2. Then we'll multiply negative 2 times our divisor. Negative 2 times x squared is negative 2x squared. Negative 2 times 0, that's just 0x. Negative 2 times negative 4, that's a plus 8.
I'm going to make sure to distribute the negative, so make sure to put the parentheses. This becomes a plus. This is a minus. And this becomes a minus. If we collect like terms, this is 12x minus 158. Now x squared times what gives you 12x? This is going to be our remainder. So we're going to put our remainder as plus 12x minus 158 over our divisor, x squared minus 4. This is our solution, 3x minus 2 plus 12x minus 158 over x squared minus 4. So please practice long division. There's plenty of homework questions, and you could always ask me. So good luck on your homework.